Welcome to my 56th tutoring session in A-level chemistry. In this video, I'll explain the electromagnetic wave, wave descriptors like wavelength, wave number, amplitude, frequency, and I'll also explain the equation governing the energy of electromagnetic radiation and how the parameters in the equation are related to each other. Electromagnetic radiation is a form of radiant energy. It can be visualized as a sinusoidal wave. The electromagnetic wave can be described by parameters like wavelength, which is the distance between two successive maxima or minima, amplitude, that represents the height of the wave, and frequency, which explains the number of wavelength units passing through the fixed point in unit time. Now, wavelength is represented by the Greek letter lambda, and wavelength is the distance between two successive maxima or minima. Amplitude is the height of the wave from the center line to the maxima or minima. Amplitude can also be defined as half the distance from maxima to minima. The maxima is also called as the crest. Minima is also known as trough. And what do you mean by one wavelength unit or one wave? Now, one wavelength unit comprises of one maxima and one minima. That will be one complete cycle. So, one wave is nothing but a complete wavelength unit, and it is constituted by one maxima and one minima. That will be one cycle for the wave. And wavelength unit is measured in meters, centimeters, millimeters, micrometers, nanometers, or picometers. Now that is about the wavelength. Now, what is the frequency? Now, frequency is the number of wavelength units that passes through the fixed point in unit time. Now, here we see that in this given fixed point, we find that two waves have passed through. And the frequency will be 2 cycles per second. So per second, you can see that 2 cycles have passed through this given fixed point. So one cycle is comprising of one maxima, one minima. So here you find two waves are passing through this fixed point, and therefore the frequency in this case will be 2 cycles per second or 2 hertz. So 1 hertz will be 1 cycle per second, 2 hertz will be 2 cycles per second. Now frequency is given by the equation c by lambda, where c represents the velocity of light in vacuum, that is 3 × 10 to the power of 8 meters per second, and lambda represents the wavelength. Now the frequency of electromagnetic radiation can be measured either in terms of time or distance. When you try to measure the frequency of electromagnetic radiation in terms of time, it will be in number of cycles per second. So 1 hertz will be 1 cycle per second. And if you try to measure the frequency of electromagnetic radiation in terms of distance, that will be considered in terms of number of cycles per centimeter length of the wave. And therefore the unit will be centimeter inverse. So we consider this particular unit in IR spectroscopy. The electromagnetic wave comprises of an electric field vector and magnetic field vector. And these two vectors are mutually perpendicular to each other. That is, they are orienting at right angles to each other. What is wave number? Wave number is nothing but the number of waves per centimeter of the wave. So it's represented by the equation 1 by lambda. Now if you are trying to measure the wavelength in terms of centimeter, the unit for wave number will be centimeter inverse. So wave number is the number of waves present in a given centimeter length of the wave. The electromagnetic spectrum extends from the high energy gamma rays to low energy radio waves. So as you move from high energy gamma rays to low energy radio waves, you can see that the wavelength increases. And as you move from low energy radio waves towards high energy gamma rays, the wavelength decreases. And what about the frequency? Now frequency increases as you move from low energy radio waves towards the high energy gamma rays. And conversely, when you move from high energy gamma rays to low energy radio waves, the frequency decreases. Now the energy for the electromagnetic radiation is given by equation E is equal to h mu, where E represents the energy of the electromagnetic radiation, h is the Planck's constant, and mu is the frequency of the radiation. Now energy and frequency are directly proportional. That is to say, as energy increases, frequency also increases. As energy decreases, frequency also decreases. But in this energy equation for the electromagnetic radiation, frequency is given by c by lambda, where c is the velocity of light in vacuum, that is 3 × 10⁸ meters per second, and lambda represents the wavelength in nanometers. So now the equation is reduced to E equal to h c by lambda. Now here in this equation, you can see that energy and wavelength are inversely proportional. So as the energy decreases, wavelength increases, and as the energy increases, wavelength decreases. So energy and wavelength are inversely proportional, while energy and frequency are directly proportional. And wave number is the number of waves present in a given centimeter length of the wave. It is the number of waves per centimeter measured in centimeter inverse. So if you try and measure the wavelength in centimeter, wave number will be centimeter inverse. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.